Hey friends, I'm just going to show how I made this guided text to speech. So you can describe a voice and ask it what to say. You can't hear this, but that's a generated uh, audio. So I managed to get it pretty fast. It should be even faster now because and very affordable. So that's only going to cost like less than a cent, like a tenth of a cent or something, like really cheap. So current text to speech probably 1 cent, so it's like 10x cheaper than a lot of other text to speech systems out there. Um, it's a fairly small model. It's about 1 billion parameters, so you don't need a big, expensive GPU. And we also, yeah, you can use this replicate space as an API. Other people are using it. This is all open source, so you can see code here. I've just done this, so we have a nice MP3 Opus encoded file coming out. So it was quite easy. I'm quite happy with replicate. This requirements.txt file does not matter, just for you to set up a virtual env with. But I mean, we go back to that chat, we can see some of the weird issues I was having with Docker. I had a few issues along the way getting this going. I did have some issues with when you run you run called predict with this prompt and with the voice. That's if you want to run it locally in Docker. You can also just run the PyTests like that. So I was having some mismatch of dependencies in these two different places. These are your local dependencies, and in this cog.yaml, this is where the actual dependencies that get installed into cog, which is the Docker hosting Docker building system that Replicate uses. So I just needed to make sure I pin all of these dependencies to the ones that my local environment had, so that I can kind of get that reproducibility going. Yeah, so this is the actual entry point, this predict.py file here. So it's quite short. Like I literally just generate with the model, write an MP3 file, and then return a path to that temporary MP3 file. And it's stored in Dev SHM, that is like a virtual memory file system on Linux. So you can see like this is actually there's not much available, so it's 32. So I actually have I think it's about how much, well, I've got 62 gig RAM here, but that's like a partition. It's loaded into RAM. Anything in there gets put in RAM basically. Yeah, so try to be quite fast. So we got this Opus, this new kind of Opus based it gets resampled as well, the speech. This is like kind of a new update instead of a WAV file. The compression rates are fairly insane. Like this is the same audio. This is like 186K. You got compressed down to this 8K MP3 file. They sound about the same, so I was quite happy with that. The main model, we did a few things to speed it up, like torch inference mode, half precision. We managed to get that working. We just half the model, and we also torch.compile the model as well, which gives us some nice performance improvements. Yeah, we created this ourselves by saving this half model and then copying the files that weren't actually saved by this. Didn't save quite all the files. Yeah, that's about it really. Like there's a few bits of pre-processing around normalizing numbers so that also like special characters as well. Like instead of the British pound character, it'll say pounds, so that the network can use like the learning that it's already done on this text. Like it'll be a familiar tokenization, familiar. They'll be able to use what it might have already learned how to say, like pound or something. That's it is based on a tokenizer, so yeah, it just kind of learns. I think the tokenization is fairly similar to an LLM. There's that must mean space. Like I've seen like that weird G that for the sensor space and other tokenization systems. That must be it. Yeah, so kind of like leading space token. Yeah, the tokenization can be very important because it's a small model. You have to be careful with the spelling to get it right. So yeah, make sure even if it's like a place name, you probably want to capitalize it. Capitalization will be different. Yeah, I think it does work in other languages. I haven't tested it too much, but yeah, there's some kind of a set range that this can replicate. Like you can change the pitch quite well. It can change male, female. I think I'm not sure if it can do like young and old, but you can describe the emotions of the voice, the pacing. Fast pacing, I would recommend because then you're going to get a shorter video. It actually detects a EOS token, so it's variable length generation. If you tell it to speak fast, it will, and then it will just terminate earlier, and you'll have a smaller file. It'd almost be nice to trim some of this now that I'm thinking about it. We could probably trim this kind of silence either side to get like better compression. Maybe I'll add that to my long list of things to do. Yeah, and let me know how it goes. Give it a try. Try the yeah. Hopefully this is helpful. Hopefully people can build some nice apps. Hopefully something accessible or yeah. So yeah, have a look at the code and let's bring the cost of intelligence down together. It's a big bit of a mission we're on. Cool. See ya.